Hello class, welcome to lesson 8.5, which is all about quadratic equations, differences of squares specifically, okay? So by the end of this lesson, you should be able to factor binomials that are the difference of squares, and you should be able to use the difference of squares to solve equations. Okay, so just remember our difference of squares looks something like this, where we have a term squared minus another term squared. So we have an example of x squared minus 25. A would be x, and B would be 5. Okay? So the way that we write our difference of squares is we have A plus B times A minus B, or the same thing, A minus B times A plus B. Okay? So you probably want to take a screenshot of this or write that down somewhere that you can see while you work on your assignment. Okay, so let's practice factoring the differences of squares. So if we look at our first example, letter A, we have 81 minus c squared. Okay, so remember we're trying to write them as a product of two, one sum, one difference. So we're talking about our difference of squares. What number do I have to multiply by itself in order to get to 81? That would be 9. Okay, so 9 times 9, that's going to give me my 81. And then how do I get a c squared? Well, I know I have to do c times c. Okay? And if I FOIL that out, I have 9 times 9, which is 81. Then I have minus 9c plus 9c, so those cancel. And then I have c times negative c, so minus c squared. Okay, so when I FOIL it back out, I end up back where I started, so I know I did that correctly. And I can continue on to my next problem. So the next problem, we have 64g squared minus h squared. Okay, so the same idea. I'm looking for what number squared gives me that 64. Well, I know 8 times 8, but I also have a variable squared with it. So I'm going to do g with my 8. So 8g times 8g, that's going to give me my 64g squared. I have a plus and a minus because we're talking about difference of squares. It's in the form a squared minus b squared. Okay, how do I get an h squared? I do h times h. And so I know that for some reason my eraser is not working, sorry. So I know that when you have a squared times b squared, or a squared minus b squared, you end up with a sum and a difference. So let's look at this next one. Is it in this format, the format we like? No, because I see we have a cubed here and another non-squared number here. So what I'm going to do first is I'm going to pull out an x because they have an x in common. So then I'm left with 9x squared minus 4. Now if I look at that 9x squared, I can say, well, this is an a squared minus b squared. So I'm going to write x, and I'm going to do what times itself gives me 9, that's 3. And then I need x times an x in order to get to my x squared. So 3x times 3x gives me that 9x squared. And then I'm going to have a plus 2 and a minus 2 in order to get to my minus 4. So this whole thing is now my answer. Okay, so just like we were practicing before, where if they have a number or a variable in common, you need to pull that out of the expression first. So at letter D, we have negative 4y cubed plus 9y. Again, we can pull a y out. I'm left with negative 4y squared plus 9. And now I have my a squared. It's not quite the a squared minus b squared that we're used to. So if I want, I can rewrite it so it matches that form. I can have my a squared minus my b squared. Okay, so that way I have the correct a and b terms. So now I have y And in order to get that 9, that positive 9, I have to do 3 times 3. And I'm going to have a plus and a minus. How do I get that 4? I'm going to have a 2, and that y squared is going to be a y and a y. Okay. So that would be how I would write that one. So make sure that it is in the a squared minus b squared form before you continue on. Why don't you try this first one on your own? Hopefully you ended up with b plus 3 times b minus 3. If you have questions, let me know. Try another one. Hopefully you ended up with 5a plus 6b times 5a minus 6b. If you have questions, still let me know, but you have one more to try. Hopefully you ended up with 5x times the quantity of x plus 2 times the quantity of x minus 2. If you have questions about that, please don't hesitate to ask. I know this stuff can be a little confusing. Okay, so example 2 is talking about applying the technique more than once. Okay, so before we were looking, well, what numbers get me to that squared? What happens when we get to a y to the 4th and there's no y over here so we can pull things out? Well, one way to rewrite y to the 4th is if I did this. If I did y squared squared, I still end up at y to the 4th. Then if I do minus 1, still I can do squared. So I have y squared squared minus y, or minus 1 squared. So if I rewrite that, my a term is going to be that y squared. I'm going to have a minus 1, because 1 times 1 is going to give me that 1. I'm going to have a y squared plus 1. Okay, so I've now simplified it once. But if I look, I still have in this parentheses my a squared minus b squared form. So I can still split this one up. So what times what gives me y squared? That's going to be a y times a y. I'm going to have a plus and a minus because it's a difference of squares. I'm going to have a 1. However, over here we have a plus sign, so I can't do anything else with that one. So this is what my final answer would look like. I have 3 separate sets of parentheses now in order to get back to that y to the 4th minus 1. Okay, let's try another one because I know it could be a little weird to see that. So if I have 4a to the 4th minus b to the 4th, okay, how can I rewrite 4a to the 4th to be in an a squared form? Well, I know if I do 2a squared squared, if I were to distribute that power of 2, that would become a 4. That would become a to the 4th. So I know that's correct. So I have 2a squared squared minus b squared squared. Now if I look at that, I have 2a squared squared minus b squared squared. So I have my a squared minus b squared form. So I'm going to rewrite it. So my first term is 2a squared, 2a squared. I have a plus, a minus. I'm going to have a b squared and a b squared. Okay? Now if I look at the minus right over here, I have 2a squared minus b squared. I know I can split that up into b squared, but there's no way for me to undo that 2. If that makes sense. I could do my a squared, but I can't really easily find a number for my 2. I would end up doing like the square root of 2. That doesn't work out nicely. So once you hit a number that you can't easily do like the square root of, you leave your answer. So we have this whole thing as our answer. Let's try another one. So we have 81 minus x to the fourth. So 81 is the same as our 9 squared minus x squared squared. So if we do that, that becomes 3 minus x squared times 3 plus x squared. And that 3 minus x squared I skipped a part. Sorry. So 9 squared minus x squared squared becomes 9 minus x squared times 9 plus x squared. Okay, sorry about that, because 9 is the number here, so that has to be my first term in my parentheses. Now I have another a squared, so that's where I get my 3, minus b squared. So I'm going to have 3 plus x, I'm going to have 3 minus x, and then I have my 9 plus x squared. But since that's a plus, I can't do anything else to it. So I'm going to circle that as my final answer. Okay, so if you ever have something that is written in this form, it needs to be simplified down further. Okay? Go ahead and try factoring this one on your own. Hopefully you ended up factoring it all the way down to y squared plus 4 times y plus 2 times y minus 2. Try one more. And hopefully for this one you ended up with 9 plus d squared times 3 plus d times 3 minus d. Okay, now we're going to apply different techniques that we have learned throughout this chapter so far. So the first thing you need to remember, and it doesn't matter what problem you're looking at, you always want to see, do these terms have anything in common? So I see that they're both even numbers, so I'm going to pull a 2 out. I'm left with y to the fourth minus 25. Now I know I have a difference of squares inside my parentheses, so I have 2 times y squared minus 5 squared. And if I were to rewrite that, my 2 stays with it, and this ends up being a y squared plus 5 and a y squared minus 5. And remember, if you put a minus here and a plus here, that's the same thing, okay? It's okay if you have a different order than I do. But now I have a y squared plus 5. Since that's a plus, I know I can't do anything with it. Is there anything I can do with the y squared minus 5? Is there any number times itself that gets us to 5 nicely? No. So I am done with that problem. Alright, let's take a look at 6x to the fourth minus 96. Okay, so if I look at this, the first thought I have is they have a 3 in common. So what I do is I take out that 3, and I see I have 2x to the fourth minus 3 goes in there 32 times. But then I realized, 2 and 32 still have a number in common. So you can pull that out as well. So I see they both have a 2, so I can say x to the fourth minus 16. So on the outside of your parentheses, you really have a 6. So I show you this because some of you ask me, how do we know what the biggest number is to pull out? It's okay to start with smaller numbers as long as you keep checking, do they have anything in common? And if they do, you keep going. If they don't, say you pulled a 6 out right away, then you're just good to go to the next step. Whatever works best for you is okay with me. So we have a 6 on the outside of our parentheses, and then my x to the fourth is the same as x squared minus 4 squared. So that becomes 6 times x squared plus 4, x squared minus 4. So I have 6, x squared plus 4, I can't change because it's addition, but the difference of squares, that's the same as x squared minus 2 squared. So I'm going to split that up again, and it's going to be x plus 2, x minus 2. Okay. So hopefully you're starting to recognize that a squared minus b squared pattern, and you know to keep splitting it up. Go ahead and try to factor this one on your own. Hopefully you ended up with 3x on the outside and then x squared plus 2 and x squared minus 2. Try one more. Hopefully you ended up with a 5 on the outside and then x plus 3, x minus 3, and x plus 5, all in parentheses multiplied together. And we're going to look at our last example for the day. So if I ask you to solve equations by factoring, and I give you 18x cubed equals 50x, and I want to know what my solutions are, the way that we are going to solve this is first to get everything on one side and set it equal to 0. It's very important that you get used to moving everything to one side and having it equal to 0. It's going to be very, very important for the rest of this chapter and for next chapter. So I'm going to move that 50x over to the other side of the equal sign by subtracting, and I'm left with a 0. And if I look at these numbers, I see that they have some stuff in common. They're both even numbers, so I know I can pull out a 2, and they both have an x. So I'm going to pull out a 2x. That means 18 divided by 2 gives me 9. I had 3 x's, took one away, so I'm at 2 x's. And then I have 50 divided by 2 is going to give me that 25, and I took away that x. So this whole thing is set equal to 0. So I have 2x on the outside, and I still have the form a squared minus b squared. So my a squared is going to be that what number times itself gives me 9? That's going to be a 3. And then how do I get x squared? I have to put an x with that 3. I need a plus, I need a minus. And what number times itself gives us 25? That would be 5. So I have 2x times the quantity of 3x plus 5 times the quantity of 3x minus 5. Now what you do is you go through, and if you look at each of these sections that I'm underlining a different color, those each represent a single number. Because once you plug a number in for x, say we plugged 1 in for x, this number right here becomes a 2. If I plug 1 in here, I have an 8. If I plug 1 in here, I have a negative 2. And then they would just all be multiplied together once I plug in an x value. So if we want to get something to equal 0, I need to have a 0 times a number somewhere in here. So I just picked random numbers. But 0 times 3 would give me 0. If I did 2 times 0 times 3, that's also 0. And same with, if for some reason this equals 4 and this equals 0, you'd still get to that 0, right? Because anything times 0 is 0. So what we're going to do, I think this is something that's very confusing for you guys yet, is you take each number and you set it equal to 0. So in this case, 2 times what number gives me 0? Well, 0. So I can go back, I can look what options don't have 0 in this case. So I can say, not this one, not this one. Okay, so that's one of my answers. Then I go to my next number, 3x plus 5 equals 0. If I subtract 5 from both sides, and then divide by 3, I have x equals negative 5 thirds. That's another answer. And I solve my last one. I say 3x minus 5 equals 0. So I add 5 to both sides. Divide by 3, I have a positive 5 thirds. So I look which of those answers has all 3. That would be letter H. Okay, why don't you try this last problem on your own? Because hopefully you ended up with letter C, or I guess not letter C, negative 9. If you have any questions about that problem or anything from the video, please be sure to reach out for some help. Have a fantastic day.